This is part two of differential calculus product rule lesson. And in this particular one, we're going to have a look at a couple of more complex examples and see how you can sort of break down your thinking to, solve the problem with a fair degree of rigorous process. Okay, so here we go. We've got in example 6, we've got ln 2x tan x minus x squared times by e to the x. So effectively what we've got here really is we've got two problems, if you like. We've got two uses of the product rule. We've got this bit here and we've got this bit here. So what we're going to do is we're going to tackle them separately and chuck it all together. So in part one, I've got u is equal to ln 2x, and therefore u dash is equal to 1 on x. We've got v is equal to tan x, and we've got v dash is equal to sec squared x, which remember means 1 on cos squared x. If any of these sorts of things you're going, oh, how did you get that? You might need to pause, go back and look at your rules, bring it all together so that you are not too confused. And then we just look at step 2 separately. So step 2 separately is u equals x squared, so u dash is equal to 2x, and we've got v equals e to the x, so v dash is equal to e to the x as well. Okay, now we put it all together, and I'm going to do that up on slide 10 there. So I've got dy by dx, dy by dx is equal to, and now I'm just going to look at part 1, and I'm going to be doing my pairing job like I did in the other 5 examples from the previous video. So inside first is u dash v. So that's going to be tan x because that is v, all over x because that's 1 on x. And we're going to add to that uv dash. So that's going to be ln of 2x multiplied by sec squared of x, like so. So that's that part done, minus, and now I need to do the rest of it. So on the second part, I've got these two paired up and these two paired up. Working from the inside out, I've got 2x e to the x, that's u dash v, plus the outside, which is uv dash, so that's going to be x squared e to the x, close bracket. Now, I reckon it's pretty important to do this step with brackets in here so you don't forget about the fact that when you're subtracting a series of terms, you have to sort of effectively bring that minus down through it. So that gives us, might put dy by dx over to the side again, so I've got a little bit more room. Dy by dx is equal to tan x over x plus ln of 2x sec squared x. You could convert to cos over cos squared x if you wanted to. Minus 2x e to the x minus x squared e to the x. And that's basically it. You could possibly simplify this further if it was useful. I can't see how it would be particularly useful in this particular one, but nevertheless, that's the way you do it. Example 7 looks deceptively easy, but I just wanted to point out what we have here is the product of 3 terms. And the way we work it is we effectively treat this as one mini problem, and then we treat this as a part 2, okay? So in part 1, we've got x squared e to the x. So I'm just going to work on the derivative of that to start with. So I've got u is equal to x squared, so u dash is equal to 2x. I've got v is equal to e to the x. I've got v dash is equal to e to the x, inside, outside. So we've got here, I'm just writing it down here, the derivative of expression 1 then, or that first part, is going to be inside, u dash v, that's 2x e to the x, plus outside, which is uv dash, that's x squared e to the x, like so. So there's my derivative for part 1. Now I'm going to go into part 2. To give myself room, I'll go all the way over to the next slide here. And in part 2, I'm now basically saying the two things I'm multiplying together is this. This is now my first function, and this is my second function. So now I'm treating this whole thing I'm circling now as u, and this second part as v. And because I've done my work, a bit of work beforehand, it's not too bad. So now for part 2, I've got u is equal to x squared e to the x. U dash is equal to, I'm just going to copy it from the bottom of the last slide. So it's 2x e to the x plus x squared e to the x there. Okay, that's u and u dash. V is simply sine of x, and v dash is equal to cosine of x. Awesome sauce. Okay, now we can just put it all together. There is one derivative. So there is one pair, there is the other pair. So f dash of x, bringing it all together, is sine of x. It's a single term, so I'm going to put it first. Sine of x multiplied by 2x e to the x plus x squared e to the x. So that's just the inside there, plus the outside, which is x squared e to the x multiplied by cosine of x, like so. And that's basically it, really. What I could do is I could do a little bit of simplification here. So, for example, I can see that there's a common x for these two terms here and a common e to the x here. So I might go, that's x e to the x outside of sine of, sorry, didn't mean to put a bracket there, x e to the x sine x outside of 2 plus x. Okay, just taking out that common factor of x e to the x plus x squared e to the x cosine of x. Maybe that's a bit better. Maybe we could go one step further and go that's equal to x e to the x outside of sine x 2 plus x plus x cosine of x. Maybe that's better. I'm not too sure. But that's pretty well much as far as we can take it, I think, in terms of simplification. You're probably wondering, when do we choose to simplify and when do we choose to leave it? And there's no great 100%. This is how you always do it. It's almost always good to have it as a single fraction if necessary. It's almost always good to factorize out common factors if you can, but results vary depending on the circumstance. It may be that the question itself gives you the hints where it says, factorize fully or something like that, or simplify as far as possible. But it is a little bit of a bit of dark magic, really, figuring out what's a more simplified form. And that sort of comes with experience a bit. But even as I said to you right now, even I, looking at these forms that I've done over these two examples, I'm a little bit like, oh, which way is the better way to express it? Is it worth putting more effort into it to simplify it or not? And so it's not a 100% simple answer to that one. Anyway, there's a couple more examples for you. Time to practice and practice and practice. What you've got here in example 6 and 7, I would suggest would be at B to A standard level. Certainly not straightforward at all, but nevertheless, you can see that you can get there. You just need to keep a clear head, break it down into smaller mini problems, solve each mini problem, and then Lego it all together into a single solution for your problem. Good luck with your practice.